This is Terry, and on this video, we're going to be simplifying rational expressions. So let's look at our first one here. We have 3c minus 12 over 16 minus 4c. So when we want to simplify a rational expression, basically we want to factor both the top and the bottom and then cancel out anything that they have in common. So we're going to start here by just looking at the top or the numerator. So I'm just going to bring it over to the side. So we have 3c minus 12, so we can work with it a little better. And we want to factor that. So we want to determine if there's anything in common that we can factor out. So we look, and they both have a number. Both terms do. So we're going to pull those numbers down. We always factor the smallest one. So we have 1 times 3. And then we look at that and we say, hey, can 3, we always start with the biggest number, can 3 divide into 12 evenly? Yes, it can. It can divide in there 4 times. So 3 will be our greatest common factor. Now, once we get our greatest common factor, if you remember, we just rewrite our original equation. So we're just looking at the top. So it's just that 3c minus 12. And then we take that greatest common factor and we just divide both terms by that greatest common factor. When we do that, that cancels out those 3's. And it leaves us with c minus, and 12 divided by 3 is 4. Then remember, you have to put those parentheses around it, and whatever your greatest common factor was, ours was a 3, you put it right in front of your parentheses. So that is going to be our top part of our equation. So we're just going to move it up here to the top. So we have 3c minus 4. All right. So that's the top completely factored. Let's look back down at the bottom. So we'll just kind of drop it down here. We had 16 minus 4c on the bottom. And we want to think what they have in common. So they both have a number. So we'll write those numbers down. We always factor the smallest one. So 1 times 4 is 4. 2 times 2 is 4. And so we start with the biggest number there, which is our 4. Can 4 divide into 16 evenly? Yes, it can. So 4 becomes our greatest common factor. All right, so what we're going to do, if you remember, we just rewrite that original part, which ours was the bottom part, so 16 minus 4c, and then we take that greatest common factor and we're going to divide both terms by that greatest common factor. So when we do that, that will actually say 16 divided by 4 is just 4, and then negative 4c divided by 4, those 4's cancel, so it leaves us with just minus c. And if you remember, we put parentheses around them, and then whatever the greatest common factor was, ours was a 4, it goes in front. So now we're going to put this, that is completely factored, we're going to put it underneath. It is the bottom part because that's where it was at before. So now we have the top and the bottom completely factored. So we would want to say, hey, is there anything we can cancel out that's in common? Well, there is nothing that's the exact same on the top and the bottom, is there? But if we look a little closer, this c minus 4 and this 4 minus c, they're basically just flip-flopped from each other, aren't they? They're inverses of each other. They're just opposites. So when we see that, anytime we see something that is the complete opposite, we literally can just cancel those out and it will make a -1. So only if they are complete opposites can they make a -1. So then we write down what we have left over. So we had a 3/4 and we have a -1, right? Times -1. And what is 3/4 times -1? It's just a -3/4. And so we have just completely simplified our rational expression. All right, so let's try another one here. I'm gonna slide my board up here. Okay, so let's look at this one. Let's say this time we have b squared plus 9b plus 18 all over b plus 3. Okay, so the same thing. We want to factor the top and then we want to factor the bottom and then put them on top of each other and see what we can cancel. So let's move the top over here. So we have b squared plus 9b plus 18. And we look and see if there's anything in common. They don't have anything in common, but I have a trinomial, so I can just put down my 2 sets of parentheses. We put the variable because it's a squared, we just put 1 in each one. And then if you'll remember, we take that last number, bring it over to the side, and then we factor it. We've done this in other videos. So 1 times 18, 2 times 9, 3 times 6, they all make 18, right? So now we are looking for which set of those can add or subtract to make that middle number, to make that positive 9. So if we look through there, we know that 3 and 6 can make 9, right? Plus 3 plus 6 makes that positive 9. And if you multiply 3 and 6, you would get that 18. So we have just completely factored the top. So we're just going to move that over here. It was b plus 3 and b plus 6. All right, let's look at the bottom. So we'll bring our bottom down. What do we have? B plus 3. Hey, I can't think of anything I can do to that to factor out. That's as simple as it can be, right? There's no numbers, there's no variables on both. So we're just going to bring that b plus 3 over to this other side. Now we have the top completely factored over the bottom completely factored. And now we're seeing if there's anything we can cancel out. Absolutely, they both have a b plus 3. So we're going to cancel that out, and all that leaves us with is b plus 6. And there's nothing else we can do with that. So that is our completely factored rational expression. All right, we're going to look at one last one here. And this time we have a squared minus 5a minus 14 all over a squared minus 4. Okay, same thing. We're going to take that top and we're going to factor that top. So we have a squared minus 5a minus 14. Nothing they have in common, but we have a trinomial that we're going to factor. So that variable goes into each one first. So it's an a and an a, right? Then we bring the last number over to the side. So we have 14. Think of ways that can multiply to make 14. What? 1 and 14, 2 and 7, and I think that is it. So now we're looking for which pair of those can add or subtract to make that -5, that number in the middle. Well, we know that is 2 and 7. So we have our 2 and we 7. And to make a -5, we'd have to have a +2 and a -7. And if you multiplied those two, you get -14. So we know that is correct. Okay, so that is going to be our completely factored top. So we're just going to put that right here. A plus 2 over a, or times a minus 7. And that's all over. All right, so let's go do the bottom real quick here. So our bottom was a squared minus 4. Well, I look at that and I'm like, haha, that's a difference of 2 squares, right? So we're going to take that variable, we put him in the first one of each, a and a. Then remember, difference of 2 squares, we always have a plus and a minus. And then the square root of 4, or what number times itself equals 4, and that is 2. So that is completely factored, and we will move that over here under our completely factored numerator. Now, we're going to cancel out what they have in common. They both have an a plus 2, right? And so what does that leave us with? That leaves us with a minus 7 over a minus 2. And that is the completely factored form of that rational expression.